My name is Jan van Doorn. I'm a lead engineer for IP CDN at Comcast, and I want to introduce you guys to the traffic control project. Even though today's CDNs are strictly controlled by open standards, and there are most of the clients of these CDNs are open source. Most of the caches in these CDNs are open source. The CDNs themselves actually are still closed source proprietary systems in almost all cases. Traffic control is a project that wants to change that. It's an open source CDN control plane, and the goals that we have is to basically create the ability to build an open source CDN using existing open source caching software, using common off-the-shelf hardware and cloud as much as we can, standards compliant, IPv6 and IPv4 from the beginning. Obviously it has to scale very well, that's what a CDN needs to do. And we want it to be loosely coupled, create as little state as possible because it gets really complicated. We want to sort of shift. I'm an old cable guy, right? I work at a cable company, been there a long time. And in cable companies, it used to be like you did maintenance at 2 a.m. in the morning, and it was like, oh my God, we're going to do maintenance. It's a big deal. We want this system to not have any of those type of problems. We want to be doing maintenance, testing, beta testing, new release software. We want to do that all the time, every day, all day. And we want it to be really, really simple. But let's first look at what a CDN really is. Obviously, a CDN is a lot of caches. You need caching proxy software, right? HTTP 1.1, workhorses that have the client connect to them and that store data closer to the edge. You need a content router, or however you want to call it. You want your customer to go to the right cache. And the right cache is usually the cache that is close to them, or the cache that is somewhat close to them but already has the content, or somebody else will be reusing that content as well. There's two ways of being good as a cache. One is you already have the content. Two is you are really close. And if you can do both, then you're a really good cache. A health protocol or a health system check. You want to know when your caches are healthy, when your caches are taking too much traffic, when your caches are ready to take new traffic, when there's maintenance going on, those type of things. Usually a CDN is dozens, if not hundreds of servers, and to manage those servers you need a system, you need something to push out software to them to manage all their settings and those type of things. And reporting is really important for a CDN as well. Usually it's used for billings purposes, but sometimes also for analytics and other things. So you want every single transaction in the CDN creates a log. You want those logs to go to a central place. So the traffic control project is addressing 4 of those 5 things. First, we have traffic router. It's a Java Tomcat application that is an authoritative DNS server. It is DNS authoritative for your CDN domain. And it's basically because of DNS, it can scale horizontally. You add more and you can do more requests per second. And it can do DNS or HTTP routing. That means that it can basically hand out when you ask for a host name, the client will ask for a host name when it goes to a URL. You can directly return a cache IP address, or you can turn your own IP address as the content router, having the client come to you, and then you can better direct it to a cache because now you know what content it's actually going for. You know what path it will go to at that host name. It uses consistent hashing to pinpoint content. If you have 7 caches in a cache group, it uses consistent hashing to pinpoint content to one cache in that cache group, and basically have all customers that go to this one asset or this one object go to that one cache in a cache group without these caches having to know about each other, share state, or do anything complicated, because we wanted it to be simple. And it's stateless. It doesn't have, one content router doesn't have to tell the other content router what it's doing or why it did that. It uses forward hashing. It always will send the same content to the same cache in a cache group, and other content routers will do the same thing, and they don't have to know what their peer just did. We have Traffic Monitor. That's our health protocol. It's again a Java Tomcat application, and it monitors all of our caches over HTTP for vital stats. And vital stats is a bit of a misnomer here. It gets probably 30 or 40 stats. There really are only 3 or 4 of these stats that we currently use to decide if a cache is healthy. One is the bandwidth, obviously. If you have a 10 gigabit Ethernet interface and you're getting up to 8.5 gigabits per second on that interface, we're going to start, not sending new customers to you because you're kind of close to that edge. Sometimes there's an overshoot. Unix load is another one. We only use Unix for anything we do, but if a cache gets to like a 25 Unix load, we're probably going to have that cache cool down a little bit and not send it new traffic. Response time, if it wasn't fast in responding to that HTTP poll, we're going to start sending customers other ways. It scales almost horizontally, and it's almost horizontally because there is a little bit of state that these traffic monitors share with each other. It is a consensus-based protocol, so you can have multiple traffic monitors in your network, and they will talk to each other and have an optimistic consensus-based view of the network that they present to traffic router. And the last one is traffic operations. It's actually the largest component of this system. It is a UI and a set of web services based on a database that has the configuration of all of your configuration and monitoring of your CDN. And there's 2 little helpers that are really not that important, and there's also REST APIs for other tools. We have a customer portal that we use as well. And then the workhorse of it all is not part of traffic control, but it basically traffic control was built around Apache Traffic Server. Traffic Server is, I think most CDNs now in some way, shape, or form are starting to use Traffic Server. It's an incredibly fast caching software. It runs really, really well on hard drives. We use a lot of hard drives in our CDN still. It's extensible. You can write plugins. You can do a lot of things to modify how it deals with the HTTP transaction. And it's basically our first cache. I hope that we will be adding support for more caches in traffic control, but this is what we've built it around first, and it's kind of our workhorse. So our status is we actually open sourced 128,000 lines of code 2 weeks ago. It was an incredible amount of work. I know more about licenses, trademarks, legal things in code than I ever would want to know. But we actually got it all through the whole machine. It's all open source now, and we're very proud of that. We have binary releases available, and the releases that are available on our website are the same that we run in Comcast. So we built a CDN on this. We're running a CDN on this. I'll get into that later. We have the documentation off to a good start. It's not just developer documentation. It's if you are a CDN administrator, you should be able to download these RPMs, look at our documentation, and build yourself a traffic control CDN. And you don't have to pay anybody anything. The one thing that we didn't do, I said a CDN was 5 things: log collection and aggregation. We haven't tackled that yet. It's on our roadmap. Obviously, Elk is a very good candidate for that, and it shouldn't be that hard to do it. It's also not a lock-in into anything, so that's why. And I'm saying the finish line is just the beginning here, because we've been running in my group like crazy trying to get to this open sourcing thing. It was a huge milestone for us, and now we're sort of trying to get the project to actually be accepted and have other people start working with us. So I'm going to do a demo here. I want to show you guys a couple things. Yeah, of course. It's not going to work, but so traffic-control-cdn.net is our website, and go over there and you can find basically the information about our software. The documentation, we did a lot of work on documentation. I personally spend a lot of time on this. There's a section on CDN basics. I get a lot of questions. Most people that get into the CDN business, have a different view of what a forward, what a reverse proxy, all these things. It sort of goes into the basics and says, this is what we as traffic control, the people making traffic control, this is what we think a forward proxy is, and this. So you sort of get a common set of terminology. There's a traffic control overview here. It will, of course, unable to connect to the internet. Should I try again? Yeah, at this resolution I can't really see anything. So I'm going to go to the demo because I can the demo on my on my own laptop. It's really the layout is not as good as you would think because it's the resolution is not good. But this is the main landing screen of Traffic Ops, and Traffic Ops is how you interface with all the components into traffic control. This basically has a list of our locations. You see we have a location. This is the Cabletown CDN. It's a fictional CDN. It doesn't actually exist. But it has locations in Houston, Los Angeles, Denver, New York, Chicago. The 6th largest cities in the country is what I picked. And what you see is this is our the locations. We're currently doing 199,181 connections and 178 gigabits per second. And one thing that you see over there is there's 2 servers that are actually have a red X there, and that means that the health protocol has turned them off. The content router is not going to send new traffic to those servers anymore because they're basically doing, if you look, 18.511 gigabits per second, and these guys have 20 gig interface, so you don't want to be sending new traffic to these guys. The consistent hashing algorithm will take care of sending it to the next server in that cache group, and you'll see a lot. What's happening here is actually, even though this is all canned data, it's actually really realistic. You'll see a lot. 1 or 2 servers in a location will be hanging against that 18.5 gigabits per second, and they'll just be, in and out. Now we only have 1 because it was just below the threshold, and it just keeps popping them in and out. I'm going to take some risk here and see if my graph at this resolution will show. And traffic control here shows us that the traffic in the last 24 hours that happened on our CDN. You can get these graphs for your whole CDN. You can get them for your cache groups, so just for Houston, just for Denver, however you lay these out. Or you can get them by delivery service. We have this thing called a delivery service, which is a grouping of content, usually a tenant on your CDN, but it can also be, a set of linear channels or something like that. Over here, there's a server check, and this is basically sort of a readiness check. You can plug in your own scripts into these columns, and you can say, for instance, that this one over here says ILO. That means is your out-of-band management interface, is that pingable by this server? Basically has all these checks. You see there's one little red cross going over here, and that was one of the servers that wasn't healthy before in the health protocol. Excuse me. It has all the things you need to enter, and again, it's laid out a little bit weird because of the low resolution. We never actually try to make these things for 480 by whatever it is, these screens, so excuse me there. But basically you can see these are my delivery services, as I call them, and in these delivery services you can basically say how you want your query string handling to be, normal things that you do in a CDN. You can set here per delivery service. You can enter your servers and put them in all kinds of states over here. And I'll click on a server. You can see basically what kind of information there is for a server. And this information combined basically creates a set of config files for Apache Traffic Server. So Apache Traffic Server, our caches will go to this central server every 15 minutes, say, hey, give me my list of config files, and this way you have complete consistency across your CDN by having this one single point of configuration management. The way that the config files get to the server really don't matter as much. You can use Puppet for that. We use our own scripts for that. What's more important is how you generate these files and make sure that they're consistent, because you don't want your content router to think, I'm going to be routing stuff to this cache, and that cache doesn't have the reverse proxy rule for it yet. Those type of things. All right, so the demo almost worked. Over here, I want to make sure if I go back here, yeah. So there's a link to our Git repository. Everything we do, every commit we make, we moved our complete development inside Comcast to open source. So every commit I make to the source code base, you can get an email for it. You can see what happens. We have a ask a question where you can basically ask questions and we'll try and answer them. We have an FAQ and downloads where you can find RPMs. So now I'm going to try and go back to the presentation. So on our roadmap, we're not just dumping this on GitHub and running away. Comcast is committed to actually continuing work on this CDN, and this is our roadmap. Interesting, we have the stats that you saw just now. They came out of a Redis database. We really want to move away from that and go on to Influx. Influx is a much better tool for that job, but it wasn't available a year and a half ago when I made this. We want to do elk analytics. HTTP 2.0 is coming fast at us, so we need to make sure that we support that. And some other things here that I'm not going to go into this. And we're looking for help. If you don't see that, you know, the line 329 here needs to be refactored and it's really not done very well, don't worry, we can use all kinds of help. We need help with Perl modulators, Go language, Java, but also documentation. Get involved with helping us out on the list. If you're working on this, ask questions, but also try and answer questions. Why does Comcast do this? A lot of people ask me, why do you do this, and why? What is in it for Comcast? I truly believe that the way that things have moved in the past for voice, when you used to call somebody on the telephone, what would happen is there were electrical wires that went connected to other electrical wires, and that ended up being a phone. It's all IP now. Video is going to go the same way. It used to be electrical wires and signals, and we call that QAM technology, how we broadcast video. It's all going to go the internet way. And Comcast is in the business of distributing video. At least my part of Comcast is. I believe that if we are not in this from the beginning, we're sort of missing it, and we sort of lose control of our own destiny. At the same time, Comcast is a company that's moving from, you know, that blue guide with the wieners to all kinds of other ways of accessing our data and accessing our media. And we're really sort of moving from all these words on the one side to all these words on the other side. We're moving from closed proprietary systems to open systems. We're moving from things that we used to buy from a vendor to things what we're building, and building in cooperation with other people. So that's sort of why we're in it. And actually, in Comcast, there doesn't seem to be a project anymore that doesn't include our CDN. So this is our design project now for design template for projects. You put the CDN in the middle already because you know you're going to need it. It doesn't matter if it's Xfinity Home, if it's voice, if it's, you name it, everything uses the CDN inside Comcast. Video is the largest user. It probably always will be, but it's not the only user, definitely not. So we're testing this thing at Comcast pretty hard. We have traffic control running at Comcast. We run it for our own internal applications, but we also have external tenants. Comcast Wholesale sells access to this CDN to deliver into Comcast. And when the gentleman from Steam was talking earlier about Grand Theft Auto being released, we noticed that on our CDN because Steam is a customer of ours, and we definitely saw that traffic go sky high. We have about 450 edges. The edge cache that we use is a 2U box with 22 terabytes of spinning disk and 1 or 2 10 gigabit Ethernet interfaces. And that adds up to about 5 terabits per second of capacity and about 10 petabyte of cache that we have out there. We have about 800 petabytes, 820 or so petabytes served. Traffic control will tell you on a daily basis how many petabytes you've served. And we do 600,000 connections easily at any given time. We've done 4 million peak, 750 gigabits per second at peak. We're currently quite heavily over-provisioned, but that's because we see this tidal wave of traffic coming our way, and we're really ready for, we are deploying IP-only set-top boxes quite heavily right now. So, so this is a little bit the way that Comcast Wholesale would like to talk us about the CDN. It's the CDN that we've built is primarily for video distribution or large file support, but we also have 7 million, I don't know, there's probably 8 million by now or 10, I don't know, it goes so fast, but our X1 set-top boxes, a lot of you have seen that new guide that we have, it looks very internet-y. All those little images are coming off of our CDN as well. Every time that they boot, they go to our CDN and they check in and see if they need new firmware. Co-download firmwares on the X1 are a fun night for us because that night we actually have the highest peak because all those guys are downloading new firmware. So it is mostly for large files and video, but not just. We do HTTP and DNS routing. Obviously, we support SSL, HTTPS. We just added DNSSEC for DNS as well. We do some content blocking and content not allowing content, but it really isn't about security as it is as much about making it harder for people. I don't think a CDN should be doing DRM. We do token-based authentication. I still don't think a CDN should be doing DRM. The object should be secure in and of itself. And you can read the rest for yourself. So I want to one more time show that link, traffic-control-cdn.net. It has all the information you need about this project. I would love for 1 or 2 persons here to actually pick that up, go there, maybe get involved, ask me questions on the forum, or come help us out. It's an exciting project, I think. And with that, I'll open it up for questions. I think I got some time. Questions? Yes, sir.
What was your use case for DNSSEC? I mean, obviously, it provides security, but what was the driver to implement it for Comcast?
The question is, what was our use case for DNSSEC? I believe that currently, and I'm not a DNS expert, but I believe currently only Google and Comcast use DNSSEC. Obviously, we all know what DNS, or maybe not. DNSSEC allows you to secure the transfer between DNS servers so that you cannot have a spoofing DNS server. Our use case is that Comcast has committed to having secure DNS servers. We are our CDN is xcr.comcast.net or top.comcast.net. We have multiple of these top-level Comcast domains, and our use case was that Comcast wants all of those transfers to be secure. It wasn't a simple feature to implement, but we're done with it pretty much.
Other DNS router, I understand global DNS is like the open DNS and Google DNS and routing to the head server appropriately?
No, I'm not sure. So if your question is, if you use Google DNS or global DNS, will you get routed appropriately? Is that your question? So we have 2 ways of routing content. One is what we call DNS routing. The other is what we call HTTP routing. In the DNS case, when you ask for an IP address of a host name, we look at your resolver's IP address and we try to get you closest to your resolver. We cannot put you close to your actual location when you use Google DNS because we don't know where you are. In the HTTP case, what we do is we send you our own IP address and then we 302 redirect you. So in that case, we can. Other questions? Yes, sir. Sorry.
You said that you're not doing any log collection and analysis. So are you doing any sort of billing from
So inside, the question was, we don't do. I said we don't do log analysis or collection with the traffic control project. How do we do our own billing? So we currently use Splunk inside Comcast. So you can easily set up, we have a syslog server that sends it into Hadoop. It is just not an integral part of the traffic control project, and it is something that I feel is lacking and that we want to add. So that's why I'm mentioning it. It doesn't preclude you from doing that at all. Obviously, we do it. So, yes. Any other questions? All right, thank you very much.